Hey guys, welcome back. In this lecture, we'll continue with the sign-up business. Last time, we learned how to set up Firebase email login, and played around a bit to get used to the main tool, which is the createUser method from the FIR class. We successfully created a Firebase user using hard code data. But we need to get this data from the email and password text field. This data is contained in the IB outlet property email text field, which we created before, in its text property. Similarly, the information users input the password text field. It's contained in the IB outlet property password text field, in its text property, to be precise. Be careful with the type here. The text property of these text fields are optional string instead of string. They might be nil because it might be the case that users touch the sign up button without inputting anything. So, let's unwrap them if we know for sure they're not nil. You can always refer to the reference to see their types and act accordingly. For more robust sign-up forms, you might want to perform optional chaining here. The idea is to proceed only when the text field, text, is not nil, if it's required. Otherwise, report something on the screen to let users know what they need to do. All right. Okay. On Firebase, we have the user 1 created in the last lecture. We'll now create another user using the input from the text fields. Okay. All right. Here it is. Let's sign up a new user. Actually, let's wait until everything is configured properly. You can see the progress in the console. Okay. All right. Okay, let's sign up a new user. Let's input some random user information. Remember to fill them out. Otherwise, the app won't run because we haven't done any error checking here. Now, hit sign up. You can take a look at the console to track the process. In the source code, we print the Firebase user object to the console if we successfully created one. So let's see if it's printed in the console by searching for it. All right, good. This is our new user. Let's check Firebase to see if it's sitting there. Okay. Let's refresh the dashboard to get the updated information. Okay. It's loading. And great. Now that we're able to create Firebase users, another question arises. Well, how can we use them? Like, if we want to get information of some users to display it on our app, on the newsfeed, for example, then how can we do it? That's why we need database. For user database, think of it like a place where we carefully and cleverly store our user data, so that we can quickly update and retrieve user information. A good database lets you do that effortlessly. As with Firebase authentication, we need tools from the Firebase to construct such databases. So in the pod file, let's specify that we will need the Firebase database library. Then, as usual, go to the terminal to install these libraries with pod. First, let's go to the project folder if you aren't already there. All right, we still need to step back on one more step to get to the project directory. Okay, good. By the way, you can type ls, short for list, quickly see what are in this directory. Our pod file is here already, so we're good. Let's use the pod install command to let pod install the libraries we specified in the pod file. You can see it's installing the Firebase database library, so that's good. Let's give it more time to finish things up. The Firebase 3 database allows real-time data handling, so it's going to be very exciting. Now, let's go to the sign up view controller source code to see where we're at now. All right, we're able to create Firebase users and receive back the user object from Firebase. Our plan now is to push this user information to the database, which is this place, in a clever way so that we can easily modify or query user information later. Just a heads up, Firebase database follows a tree structure with nodes, child nodes, and things like that, but we'll see. All right, we talked all cool things about the Firebase database and that we need to store user data there. But where is it exactly? We can't do anything without knowing where it is. So let's create a constant using it we can communicate with the Firebase database of our app. We'll get the location of the Firebase database for our app and assign it to this constant. To be able to get information about this location, we need some tools in the Firebase database package we've just installed. After importing these Firebase database package, we can then use tools from the FIR database class. Let's create an instance of this class to use the tools. The tool we need for our current goal is this reference method. Option-click this method, we can see that it sort of gets a reference to the root of the Firebase database of our project. It basically returns a reference to the location where our Firebase database lives. Note that this location ties with the Firebase project. So your database location is not the same as mine. This is the database of my Firebase project. So this ref constant now simply contains that information. Let's print it out. Option-clicking the reference method again, you'll see that it returns an FIR database reference object. Ref is now such object, which has a method called description, returning the string describing the database location. Actually, let's do this before the createUser method for now for testing. You should click here to set a breakpoint so that the app will pause at this step. We just want to see how this reference method works and what it gives us. We'll move them down later. For now, when we hit the sign up button, these two commands will be executed and the app will stop there. All right, let's touch that button. Actually, let's move it somewhere else to see the console. Okay, the app stops at the breakpoint. This is the database root location of my Firebase project in the string format. It's exactly this address here on Firebase. All right, so now we know where our app's database lives. Precisely, we can communicate with it via the ref constant. To clean up, stop the project, then drag the breakpoint out of its place to clear it. Now, get back to our business. We don't need the print commands anymore. All right, let's see. Okay, let's fix this annoying warning. Okay, Xcode offers a few ways to fix it, but let's see. This command can only be executed if the if statement is true, meaning the error is not nil. That means we can safely, forcibly unwrap the error. Great, there's no more warning. That's much better. All right, we want to push newly created users to the Firebase database. We're going to need this constant to reference to the database location. As Firebase database follows a tree structure, our idea is to represent all users as a big node and make each user a child node of it. So let's define a constant called users reference to reference this big node on the user database. The database is still blank, so we need to create this node. We create a new child node of the root reference using the child method, and the string input is a relative path. Now this user's reference constant and the ref constant are the same type. They both reference to some specific location on the Firebase database. When we create the new node this way, this new location will be like whatever the root location is / users. Actually, you can print out the user's reference constant to see where it references to. It's an FIR database reference object, which has description method that prints out the referenced address in the string format. Actually, to save time, we're not going to run the app now, but if you run the app, the following will be printed out. Okay, let's comment out this line. So the following will be printed out. The root location / users. Okay. All right, good. Now for each new user, we'll create a new child node of this big node. Then save this new user information in that node. This is where we need to do things cleverly. A crucial point that we need to make sure is each user address must be uniquely identified. Otherwise, we can't distinguish them. All right. Later on, when you already master Firebase, for this new user, you can just append the new node for it. Directly here using the child method as before. The input would then be the relative location. But for now, let's proceed slowly. Let's create a new child location of the location of all users and define a new constant to reference this location. Let's name this constant, let's see, new user reference. This constant will be a reference to the new user location on the database. So, let's create a new child node of the location of all users using the child method. Now, the input of this method is the relative path. By looking at this relative path, one should know exactly which user information this node contains. So it's kind of like the ID of this user on the database. Now let's decide what should be the use for this ID. Because it must be able to tell what user it refers to, it must be something related to the new user. Right now, for each newly created user, we know 3 pieces of information: the username, the email, and the Firebase user ID, as we see under the Users tab in the Authentication section on Firebase. We can get all of this information from the user variable. Because this database ID should be unique, an excellent choice is the Firebase user ID, which we can get from the UID property of this Firebase user object. If you don't remember, this user variable is the new Firebase user object we get from Firebase. My bad. These things are actually the same. All right, let's step back to see what we've done. This new user reference now points to the new user node on the database. If you print it out in the string format using its description method, it will be this string, then slash user ID. One point must be made very clear here. The UID of each Firebase user is created by Firebase when the user was created using the create user method above. Now, when we push this new user to the database at some unique location, we use that UID for the relative path of this location. Okay, good. Now let's store the user information at this node. We push information data to each Firebase location using the setValue method. Actually, let's fix this annoying error. All right, we need to forcibly unwrap this constant because the user object is optional, as the user creation process might fail. So this constant is optional. We can safely unwrap it because we already check error above. All right, we use the setValue method of this object to save data to the database location it references. What data and how you save it is up to you, but it's common to save data in dictionary format. In this app, we store usernames to the database so that we can display them on news feeds or whatever. This is the username users input in the signup view. Precisely, it's the content of the username text field. We forcibly unwrap this optional string, but you should check nil here. Next, we also want to store user emails so that we can display them in the user profiles. This information is the content of the email text field in the signup view. Okay, programmatically, there's no reason we can't store user passwords on the database. However, ethically, we don't want to do so. We should just let Firebase handle the passwords for authentication. Other than that, let's keep them secret. All right, you must be very careful here. Note that we're operating in a closure. In Swift, the compiler requires us to use the self keyword in a closure when we want to access an instance property. Self here refers to the signup view controller itself, and this is the closure we're talking about. It's executed after the user creation process finishes. In this closure, we're trying to access some instance variables of this signup view controller, and self is simply the signup view controller itself. If we try to access these properties in this closure without the self keyword, the code won't compile. All right, good. Actually, before checking out the app, let's print out this new user reference constant to see what it looks like. Recall that it's an FIR database reference object. So we can print what it references in string format using its description method. All right. If you want to quickly spot the printed text, you can use string interpolation here. Basically, this slash parentheses syntax turns the parameter inside the parentheses into a string. We can then use string concentration to print out a descriptive piece of information. All right. Just put any meaningful text here, like a new user location or things like that. Here I use description for short. Not a great one, but anyway, it works. All right, let's check it out. Note that at the child method, given a relative path, if the corresponding location exists, this method returns a reference to that location. If the location doesn't exist, it creates the node before returning to the reference. So here that method must create the node for all users first. All right, let's create a new user. My bad, this is the sign in view actually. This will be user 3. Her email is going to be user3@gmail.com and the password is 123456. Sign in. Oh, we expect to see the node for all users and then for the new user. Fantastic, it's in real time. This is the node for the new user, which stores the username and user email. Now let's remember the relative path for the node, which starts with J, J9, and stuff. In the console, we can see the full absolute path of the location for this new user. It's exactly what we've just seen on the database, which is root/users for all users and / the new node relative path. This whole absolute address is encoded in this new user reference object, in which the relative path is set to the Firebase user ID. Also, if you look back at the setValue method of the new user reference, it simply stores data to the reference location, the new user location. Here we store user information in dictionary format, which resembles JSON, one of the most dominant and efficient data formats. All right. So we know how to construct a good user database to exploit Firebase real-time database. Next time, we'll further study Firebase real-time data handling and Firebase storage. All right, see you then.